Okay, so a lot of time is spent in algebra learning how to solve equations and then solving them for various purposes. So it goes without saying that we really need to understand what it means for something to solve an equation. So first, let's make sure we understand what an equation is. An equation is simply a statement about the equality of two expressions. In other words, anything that takes this form. So when you have one expression that is equal to another expression. So which of the following is not an equation? So really all you're looking for is an equal sign. Number 1 has an equal sign, number 2 has an equal sign, but number 3 does not, and number 4 does. So you're looking through which one has an equal sign. So exercise number 2, consider the equation 2x minus 8 equals 10 minus x. So why can you not determine whether this equation is true or false? Well, you can't determine if it's true or false because we don't know what it is for x. We don't know what x is. So we don't know x. We don't have a value for x. So now, if x equals 5, will the equation be true? How can you tell? So we're going to plug 5 in for that equation. So 2 times 5 minus 8 equals 10 minus 5. 2 times 5 is 10, and 10 minus 5 is 5. 10 minus 8, does that equal 5? No, it does not. It is false. The next thing is we're going to take that same equation and show that x equals 6 makes the equation true. Remember to think very carefully about your order of operations. So we do 2 times 6 minus 8 equals 10 minus 6. So everywhere there was an x, we put 6. 2 times 6 is 12. 10 minus 6 is 4. 12 minus 8 is 4. And yes, 4 equals 4. So it is true. A value for a variable is called a solution to the equation if, when substituted into both expressions, results in the equation being true. So this is a solution to equation. X equals 6 is true. So the concept of the solution to an equation is amazingly important. It implies that you can always know when you have solved an equation correctly. As long as you can check the truth of the equation with arithmetic, then you know if your value of x is correct. So determine whether each of the following is a solution to the given equation. So all that you're doing is you're going through and you are solving. So the first one, 2 times 7 plus 3 equals 17. 2 times 7 is 14. 14 plus 3. Does 17 equal 17? So yes, that is true. Letter B, we're plugging 10 in. So 10 minus 20 divided by 5, does that equal negative 4? So 10 minus 20 is negative 10 divided by 5, does that equal negative 4? There's no way that negative 10 divided by 5, which is negative 2, equals negative 4. So no. Letter C. 2 times 4 plus 5, does that equal 6 times 4 minus 1? Well, 4 plus 5 is 9. 4 minus 1 is 3. Does 18 equal 18? Yes. Next one. Negative 1 squared minus 1, is that equal to 2 times negative 1 plus 2? Well, negative 1 squared is 1, because that's negative 1 times negative 1. And 2 times negative 1 is negative 2. So now I have 0 equals 0. So yes, it's true. My next one, we are plugging 2 in for x. So 3 times 2 plus 2 divided by 4 minus 1 equals 5. 2 plus 2 is 4, so 3 times 4 divided by 4 minus 1 equals 5. Okay, and then 3 times 4 is 12. Divided by 4 is 3. So now I'm going to move, so that went there. We're going to move this up here. 3 minus 1 does not equal 5 because 2 does not equal 5. So no, that is not true. And last one, letter F. If we plug 8 in, 3/4 of 8 minus 1, is that equal to negative 1/2 of 8 plus 9. So 8 times 3 is 24, divided by 4 is 6. Negative 1 times 8 is negative 8, divided by 2 is negative 4. Does 5 equal 5? You betcha. So I think that this is kind of funny that they call it no excuse land, but whatever. So if you solve an equation, you would always be able to check to see if your solution is correct. Sometimes mistakes happen, and it is good to be able to spot them. So Kirk was checking to see if x equals 7 was the correct solution to 4x minus 3 equals 2x plus 11. He concluded that it was not a solution based on the following work, so was he correct? So 4 times 7 minus 3 equals 2 times 7 plus 11. 4 times 7 is 28 minus 3. 2 times 7 is 14 plus 11. 28 minus 3 is 25, which equals 25. So where did Kirk go wrong? He did the wrong order of operations. He did 7 minus 3 first and then multiplied 4 times 4.